Imagine this. Right now, as you sit here, the universe could be splitting into countless versions of itself, each one home to a slightly different you. One where you chose a different career, another where you missed that train this morning, and maybe even one where you're a world-renowned astrophysicist unraveling the secrets of the cosmos. Sounds like science fiction, right? But what if I told you that this idea, the quantum multiverse, isn't just a Hollywood plot device, but a serious theory grounded in the strange, mind-bending world of quantum mechanics? By the end of this journey, you'll not only grasp the wild possibilities of parallel universes, but also wrestle with a concept so provocative it might keep you up at night. Quantum immortality. Could you, in some version of reality, live forever? Stick with me, hit that like button if you're as curious as I am, and let's dive into a story that begins over a century ago and still challenges everything we think we know about reality. Our story starts in the early 1900s, a time when the world of physics was buzzing with excitement and confusion. Brilliant minds like Albert Einstein, Max Planck, and Erwin Schrödinger were piecing together a new way to understand the universe: quantum mechanics. This wasn't just a tweak to existing theories, it was a complete overhaul of how we thought reality worked. By treating light as both a particle and a wave, scientists began solving mysteries that had stumped them for decades. From explaining how atoms emit light to predicting the behavior of subatomic particles, quantum mechanics was a game changer. It's the reason we have computers, Wi-Fi, GPS, and even the LED lights illuminating your screen right now. But here's where things get weird. In the classical physics of Isaac Newton, everything was precise. You could measure exactly where a planet was, how fast a car was moving, or how much you weighed on a scale. The universe was a predictable machine, like a cosmic clock ticking with certainty. Quantum mechanics, however, threw that certainty out the window. Instead of exact measurements, it gave us probabilities. A particle's position or speed wasn't definite until you measured it. It existed in a strange state of possibility, described by something called the wave function. This mathematical tool told physicists the likelihood of finding a particle in one spot or another. For example, there might be a 25% chance a particle is here, a 25% chance it's there, and a 50% chance it's somewhere else entirely. This probabilistic nature baffled even the greatest minds. In the 1920s, Niels Bohr and Werner Heisenberg proposed the Copenhagen interpretation to explain it. They argued that the wave function collapses when an observer measures the system, locking in one outcome from all the possibilities. It's as if reality only snaps into focus when someone looks at it. Weird, right? Albert Einstein certainly thought so. He famously quipped, "God does not play dice with the universe," rejecting the idea that reality could be so random. And then there was Erwin Schrödinger, who came up with his famous Schrödinger's cat thought experiment to show just how bizarre this idea was. Picture a cat in a box tied to a quantum event that could leave it either dead or alive. According to the Copenhagen interpretation, until you open the box and look, the cat is both dead and alive. A superposition of states. It's not just a metaphor. Quantum mechanics suggests this is how reality works at its smallest scales. This paradox sparked heated debates. Why does observing something make it real? Could human consciousness somehow be the key to collapsing the wave function? The equations of quantum mechanics worked so well that they powered modern technology, but the underlying why remained a mystery. It was a puzzle that frustrated physicists and set the stage for a radical idea that would change everything. If you're already feeling your brain twist, drop a comment below with your thoughts. I'd love to hear how this is landing with you. Enter Hugh Everett, a 27-year-old American physicist who, in 1957, proposed a solution so audacious it shocked the scientific world. What if the wave function never collapses? What if, instead of one outcome being chosen and the others disappearing, every possible outcome happens, each in its own separate universe? This was the many worlds interpretation of quantum mechanics, and it was nothing short of revolutionary. Let's break it down with a simple example. Imagine an electron that could move either left or right. In the Copenhagen interpretation, the electron exists in a superposition, a mix of both possibilities, until it's observed, and then the wave function collapses, picking one path. The other possibility vanishes, never to be seen again. But Everett's idea was different. He suggested that when the electron faces this choice, the universe splits into two distinct realities, one where the electron goes left and another where it goes right. This process, called branching, means that every quantum decision creates new universes, each following its own unique path. And since our universe is teeming with particles making quantum choices every instant, this branching happens at an almost unimaginable rate, creating a near infinite number of parallel universes. In one universe, you're watching this video right now. In another, you decided to go for a walk instead. There's even a universe where you're a quantum physicist debating Everett's theory with colleagues. Here's the mind-blowing part. Your consciousness, according to many worlds, is just along for the ride in one of these countless branches. There's a version of you in every universe where a different quantum outcome occurred, each living its own distinct life, completely unaware of the others. These universes can't interact or communicate, locked away in their own realities. When Everett took this idea to Niels Bohr in Copenhagen, the elder physicist dismissed it as too extravagant. The scientific community largely stuck with the Copenhagen interpretation, and Everett, disheartened, left academia, never publishing in physics again. But his idea lingered, slowly gaining traction as physicists began to wrestle with its implications. If this is sparking your curiosity, hit that subscribe button to join us as we explore more mind-bending science. For years, the many worlds interpretation faced a big problem. If the wave function never collapses, why do our experiments always show a single, definite outcome? Why don't we see the blurry superposition of all possibilities? The answer came in the 1970s with a breakthrough called decoherence. Picture a quantum system in isolation, like a particle floating in a perfect vacuum. Its wave function is clean and predictable, like a clear radio signal. This state is called coherence. But in the real world, particles don't exist in isolation. They're constantly bumping into atoms, photons, and other environmental factors. These interactions cause the quantum system to become entangled with its surroundings, scrambling the wave function like static on a radio. This process, decoherence, explains why we only see one outcome in our experiments. The other possibilities don't vanish. They're still there in other branches of the multiverse, but they're locked away, entangled with the environment in a way that makes them invisible to us. To a Copenhagen believer, this looks like the wave function collapsing. But in many worlds, it's more subtle. Decoherence sorts each outcome into its own non-interacting universe. This was the missing piece that made many worlds a serious contender. It kept all the predictive power of the Copenhagen interpretation without needing a mysterious collapse triggered by an observer. No longer did human consciousness have to play a special role. Reality itself was doing the heavy lifting. Today, as of August 23rd, 2025, the many worlds interpretation is gaining ground. A recent poll by the American Physical Society suggests about 22% of physicists now lean toward many worlds, up from 20% a few years ago, though Copenhagen still holds sway at around 40%. The rest are split among other interpretations or remain undecided, reflecting the ongoing debate. The multiverse isn't just a theory, it's a challenge to our understanding of reality itself. What do you think? Does the idea of countless parallel universes excite you or freak you out? Drop a comment and let's keep the conversation going. The many worlds interpretation doesn't just challenge physics, it forces us to rethink what it means to be human. If every quantum event spawns a new universe, there are countless versions of you out there, each living a slightly different life based on every possible outcome. In one universe, you aced that job interview, in another, you missed it because of a flat tire. In one reality, you're happily married. In another, you're traveling the world solo. This raises profound questions about identity. Are all these versions of you equally you? Or is the real you the one experiencing this particular branch of reality right now? The idea that your consciousness is just one thread in an infinite tapestry of possibilities can be both exhilarating and unsettling. It suggests that every choice, every chance event creates a new reality where another you is living out the road not taken. If this is blowing your mind, share your thoughts in the comments. What would you ask another version of yourself if you could meet them? This philosophical puzzle extends beyond personal identity to the nature of free will. In the many worlds framework, every possible choice you could make does happen, just in different universes. Did you choose to watch this video, or was it inevitable in this branch while another you chose differently? The multiverse suggests that free will might be an illusion, not because your choices are predetermined, but because every choice is realized somewhere. This can feel liberating, as it means no decision is truly wrong or daunting, because it fragments your sense of self across infinite realities. Philosophers like David Lewis and Derek Parfit have grappled with these ideas, arguing that the multiverse challenges our traditional notions of selfhood and morality. If every action happens somewhere, how do we define responsibility? These questions aren't just academic, they strike at the heart of how we live our lives. Let's keep exploring these big ideas together. Hit that like button if you're ready for more. One of the biggest criticisms of the many worlds interpretation is that it's hard to test. Unlike the Copenhagen interpretation, which makes the same mathematical predictions but assumes a single universe, many worlds posits countless parallel realities we can't directly observe. So how do we know if it's true? As of August 23rd, 2025, physicists are devising creative ways to probe the multiverse indirectly. For instance, experiments at facilities like the Large Hadron Collider at CERN are pushing the boundaries of quantum mechanics, looking for anomalies in particle behavior that might hint at interactions between branches. Recent studies from the Perimeter Institute in Canada suggest that subtle effects in quantum entanglement could provide clues, though results are still inconclusive. Another avenue is cosmology. Some researchers propose that patterns in the cosmic microwave background, radiation left over from the Big Bang, might carry signatures of other universes, though 2025 data from the James Webb Space Telescope hasn't confirmed this yet. Another promising field is quantum computing, which we touched on earlier. Some physicists argue that the sheer computational power of quantum systems could be evidence of parallel universes working together, as David Deutsch suggests. In 2025, advancements in quantum error correction and qubit stability have brought us closer to practical quantum computers, but they haven't definitively proven many worlds. Critics argue that we may never directly observe other universes, as decoherence ensures they're forever out of reach. Still, the search continues, driven by curiosity and the hope that new technologies or mathematical breakthroughs will shed light. What do you think? Will we ever find proof of the multiverse, or is it destined to remain a thought experiment? Drop a comment with your take, and let's see what the community thinks. The multiverse idea gets even wilder when we look at quantum computing, a field that's exploded in recent years. As of August 23rd, 2025, companies like IBM, Google, and Quantinuum have pushed quantum computers to new heights, with systems now handling hundreds of qubits, the quantum equivalent of bits in classical computers. Unlike classical bits, which are either 0 or 1, qubits exist in a superposition, embodying both 0 and 1 simultaneously. This allows quantum computers to perform multiple calculations at once, exponentially faster than classical systems. For example, a quantum computer with 300 qubits can, in theory, perform 2 to the power of 300 calculations in parallel, a number so large it dwarfs the number of atoms in the observable universe. David Deutsch, a leading physicist and advocate for many worlds, argues that this computational power is indirect evidence of the multiverse. He suggests that when a quantum computer runs these parallel calculations, it's tapping into the resources of other universes, each handling a different part of the computation. It's a bold claim, and not everyone agrees. Critics argue that quantum computing can be explained without invoking parallel universes. Still, the idea is tantalizing. Companies like Quantinuum reported in 2025 that their latest quantum processors achieved breakthroughs in solving complex problems, like optimizing supply chains and simulating molecular interactions, tasks that would take classical computers billions of years. If Deutsch is right, every time we run a quantum algorithm, we might be glimpsing the multiverse at work. Want to dive deeper into quantum computing? Give this video a like and let me know what topics you'd love to explore next. Now, let's tackle the most provocative idea yet, quantum immortality. If the many worlds interpretation is true and the universe splits with every quantum event, what happens when you face a life or death situation? Imagine a car crash with two possible outcomes. In one branch, you survive. In another, you don't. According to quantum immortality, your consciousness always follows the branch where you survive. In every universe where a version of you could live, you do, potentially forever. It's not that you're invincible, it's that there's always a universe where you dodge the bullet, literally or figuratively. This idea stems from Hugh Everett himself, who reportedly believed his many worlds theory guaranteed his immortality. While he never published this view, accounts from colleagues and family suggest he took it seriously, perhaps even betting his life on it. But quantum immortality is controversial, even among many world supporters. Critics argue it stretches the theory beyond its limits, confusing physical possibilities with subjective experience. After all, the you in each branch is a distinct entity, unaware of the others. If one version survives, does it really count as you living forever? And what about aging or disease? Can quantum branching outpace those? Recent discussions in 2025 on platforms like X highlight a growing public fascination with quantum immortality, with some users speculating about near-death experiences as evidence. Though scientists remain skeptical, as of 2025, there's no experimental evidence for quantum immortality, and it remains a thought experiment. But it's a compelling thrilling one. Think about those moments when you've had a close call, a near miss on the highway, or a lucky break. Could those be glimpses of your consciousness navigating the multiverse, always landing in the branch where you survive? It's a lot to wrap your head around, and it raises deep questions about identity and existence. If this idea has you hooked, share your thoughts in the comments. What would you do if you knew there was a universe where you never die? The idea of the multiverse has transcended the halls of academia to capture the public's imagination, becoming a cultural phenomenon by August 23, 2025. From blockbuster films like Spider-Man, Across the Spider-Verse, to best-selling novels like Blake Crouch's Dark Matter, the concept of parallel universes has inspired storytellers to explore themes of choice, identity, and destiny. These narratives resonate because they tap into a universal human experience, the what-ifs of life. What if you'd taken that job offer? What if you'd said yes instead of no? The multiverse gives us a framework to imagine those alternate paths, not just as hypotheticals, but as real, lived realities in other worlds. This storytelling power has made the multiverse a staple in pop culture, sparking debates on platforms like X, where fans discuss whether their favorite characters' choices in one universe could ripple into another. Have you seen a multiverse story that blew your mind? Share it in the comments. I'd love to hear your favorites. This cultural fascination isn't just entertainment, it's a reflection of how quantum mechanics is reshaping our worldview. In 2025, educational platforms like YouTube and TikTok are buzzing with creators breaking down complex physics for millions, often using the multiverse as a hook to draw in curious minds. Museums and science centers, like the Griffith Observatory in Los Angeles, have launched exhibits exploring quantum mechanics and the many worlds interpretation, drawing record crowds. These efforts show how the multiverse isn't just a scientific theory, but a lens through which we explore human potential and possibility. It's a reminder that science doesn't just explain the world, it inspires us to dream bigger. If this intersection of science and culture excites you, hit that subscribe button to join our journey into more cosmic ideas. As we stand on August 23, 2025, the future of quantum mechanics and the multiverse is brimming with possibility. Researchers are pushing the boundaries with experiments that could one day tip the scales in favor of one interpretation over another. For example, advancements in quantum gravity research, like those at the Kavli Institute for Theoretical Physics, aim to reconcile quantum mechanics with general relativity, potentially revealing whether the multiverse is a necessary piece of the cosmic puzzle. Meanwhile, projects like the European Space Agency's Euclid mission are mapping the universe's large-scale structure, searching for clues that might support multiverse theories tied to cosmic inflation. These efforts, while still in early stages, could reshape our understanding of reality in the coming decades. What breakthrough do you hope we'll see in quantum physics? Drop a comment and let's dream about the future together. Beyond experiments, the practical applications of quantum mechanics are accelerating. Quantum cryptography is becoming a cornerstone of cybersecurity, with companies like ID Quantique deploying unhackable communication systems in 2025. Sensors are revolutionizing fields like medicine and geology, offering unprecedented precision in detecting everything from brain activity to underground mineral deposits. These technologies don't directly prove the multiverse, but they underscore the power of quantum mechanics to transform our world. If many worlds is correct, every quantum innovation might be leveraging the unseen branches of reality. This blend of theoretical wonder and real-world impact is what makes quantum mechanics so thrilling. It's not just about understanding the universe, but about shaping our future within it. Let's keep the conversation going. Share your thoughts on where quantum tech is headed. At its core, the multiverse isn't just a scientific concept, it's a deeply human one. It speaks to our curiosity, our desire to understand our place in the cosmos, and our longing to explore the paths not taken. The many worlds interpretation invites us to imagine a reality where every possibility plays out, where every version of you gets a chance to shine. This can be comforting, suggesting that somewhere out there you're living your best life, or humbling, reminding us that our choices are just one thread in an infinite web. It's a perspective that encourages empathy. After all, if every person exists in countless versions, each facing their own struggles and triumphs, it deepens our appreciation for the shared human experience. Have you ever wondered what another version of you might be like? Share your thoughts in the comments, and let's connect over this cosmic idea. This human connection also drives the scientific quest. The physicists of today, like their predecessors a century ago, are motivated by a passion to unravel the universe's mysteries. In 2025, initiatives like the Quantum Flagship in Europe and the National Quantum Initiative in the US are fostering collaboration among scientists, engineers, and educators to push quantum research forward. These efforts aren't just about solving equations, they're about answering questions that have haunted humanity for centuries. Why are we here? What is reality made of? The multiverse, with its infinite possibilities, reminds us that science is a journey of discovery, one that invites us all to participate. Whether you're a physicist or just a curious soul, the multiverse challenges you to think bigger. If this inspires you, give this video a thumbs up and join our community of cosmic explorers. We've traveled from the birth of quantum mechanics to the edge of the multiverse, exploring ideas that challenge our understanding of reality. The many worlds interpretation suggests that every choice, every quantum event spins off new universes, each with its own version of you. Decoherence explains why we only see one outcome, while quantum computing hints at the multiverse's computational power. Quantum immortality pushes the boundaries even further, asking whether we might be eternal passengers in an ever-branching cosmos. These ideas aren't just scientific, they're deeply personal, forcing us to question who we are and what reality means. As of August 23rd, 2025, the debate between Copenhagen, many worlds, and other interpretations is far from settled. Advances in quantum technology and experiments, like those at CERN or the Perimeter Institute, continue to probe the nature of reality, but we're still a long way from definitive answers. What we do know is that quantum mechanics has transformed our world, powering everything from smartphones to medical imaging. The multiverse, whether real or not, forces us to confront big questions. What is reality? Who are we in the grand scheme of things? And what does it mean to exist in a universe, or universes, where every possibility plays out? I hope this journey has sparked your curiosity as much as it has mine. If you enjoyed this deep dive, give the video a thumbs up, share it with a friend who loves big ideas, and subscribe for more explorations into the mysteries of the universe. Let's keep the conversation going. Drop a comment with your thoughts on the multiverse, quantum immortality, or what you'd like me to cover next. Are you Team Copenhagen or Team Many Worlds? And if you're wondering about the practical side of all this, check out tools like Odoo, which streamline business tasks so you can spend more time pondering the cosmos. Thanks for watching, and I'll see you in the next universe, or maybe this one.